Hello, everyone. Today we are going to take a look at chapter 1.2, which is titled Adding Integers. Our essential question for today is how can you use what you know about adding integers to add rational numbers? And then our question in the left-hand column is how do you add decimals with the same signs and different signs? So one of our main rules for adding decimals, right, whether you remember it or not from previous years, is first to actually line up your decimals. So if I have this problem written right, horizontally, I'm going to write it vertically, lining up the decimals so that they're on top of one another. And one of your main rules that we are going to learn this year when you're adding integers is if the integers have the same signs, meaning they're both positive numbers or they're both negative numbers, well, your same signs you're going to add. And you're going to keep the sign the same. If your integers have different signs, well, then you subtract. And when you subtract, you keep the sign of the bigger number. And we'll get more in detail, right? Or more in depth on this as we go on, but it's something that we're going to be utilizing throughout the whole school year. And this is actually never going to go away. You're going to use it from now in math from now on till you graduate high school. And if you go on to college, you're going to keep using this rule. It's same signs add. And when they add, you keep the signs the same. Different signs subtract. And when you subtract them, you keep the signs of the bigger number. So here I have two negative decimals, negative 12.6 plus negative 3.93. So I'm going to ignore for the negatives for a second because I know that this is a negative and this is also a negative. Because they are the same signs, I am going to add them. So I'm going to ignore these for a second and just line up my decimals and add them. So I have placed a 0 at the end, right, as a placeholder. So I know that there's a 0 there. 3 plus 0 is 3. 9 plus 6 is 15. So 5 goes there. Carry the 1. 3 plus 2 is 5. Plus 1 is 6. And the decimal, I have to bring that down since I lined them up already. And this one just comes straight down. So 12.6 plus 3.93 is 16.53. Now, these were the same signs, so I have to go ahead and keep the sign the same and place a negative there. Now, to go more into detail as to why we keep the sign the same, it is kind of like if you're adding, let's say, let's ignore the decimals for a sec. Let's say you had 12 apples, right? And I give you 3 more apples. Well, you would have 15, right? And that is because these are both negatives, or in that example I just gave you, they're both apples, you'd add them together because you are accumulating or accruing more. But if that quite didn't make sense, we will keep looking at this, right, with more examples. So let's go ahead and look at this example more in detail. I'm going to go ahead and bring it up here so that I can write on it. Okay, so here it says find negative 2 plus, and in parentheses, negative 4. Use the number line to check your answer. All right, well, here it says negative 2 plus negative 4 equals negative 6. And it says use the common sign. So what that means is we are utilizing this rule that we just learned. Your same signs add. Now, if it's difficult to follow that rule, there's a couple different ways we can talk about this. Now, this is a negative 2, right? So what we did was we put two negatives here. Right? Here's a negative, here's another negative. Okay, to symbolize my two negatives. Now I'm going to add on four negatives. So I'm going to write 1, 2, 3, 4 negatives. Well, if I have two negatives, and then I give you four more, in total you have six negatives. All right. So my answer to this is -6. And that is why our same signs add, keep the sign the same. We can also use a number line. All right, so we are always starting off at 0. Then we go to -2 because -2 is our first number. So I go 1, 2. Now that when I'm at -2, I add -4. Well, in the number line, when you go in the negative direction, you go to the left. So I'm going to go to the left 4 spots. 1, 2, 3, 4. And look where I end up. I end up at a -6. So I started off at 0 because that's the center. I'm going to go to the left because that's my first number, -2. And then I'm going to go 4 more to the left. So 1, 2, 3, 4. And I end up at -6. Another way to use or to solve this could be using absolute value, which we learned in the last section. So I could add the absolute value of -2, which is 2, and then add the absolute value of a -4, which is a +4. And 2 plus 4 will give me 6. If you're going to do this, however, you cannot forget the rule that says the same signs. When you add them, you have to keep the sign the same. So you have to use the common sign. So this would turn into a -6. So if this didn't quite make sense, you can go ask me a question. Or if you just feel like you need to watch the lesson again, you can go ahead and rewind it a bit and see what I did, right? And to get a -6. But we're also going to continue getting more practice. So let's look at these practice section, and then we'll go more into. All right, so to practice these, we first line up our decimals, which I have set up for you all already by lining up. Now we're going to take a look at our rules, and we're going to figure out if we actually add these or subtract these based off of that rule. So let's take a good look at our first one. So I'm going to start off by writing the signs of our numbers. And this is what I mean. Okay, this is a -4.05. So I'm going to place a negative right there. This one right here is a positive 7.62. So this is going to be a positive number. Well, look, I have a negative and a positive. These are different signs. So if they're different, let's go back and let's look. Okay, we'll line up the decimals, check. Right here, different signs, subtract, and we keep the sign of the bigger number. Okay, so this is my main thing right here, subtract. So I know I'm going to go ahead and subtract these. Now, the bigger number is the 7 right here. So my answer is going to be a positive. Over here, I have a negative. Right here, I have a positive. Again, they're different signs. So I'm going to keep the sign of the bigger number, which is this one right here. So my answer is going to be a positive, but because they are different, I'm actually going to go ahead and subtract these. And over here, I have a negative plus -4.3. Well, look, now I have the same sign. And when I have the same, I'm going to go ahead and add them. When I add, I have to keep the sign the same. So this is a negative, this is a negative. Your answer is actually going to be a negative. Now, what confuses people with these, I showed you why we are subtracting, because these are different. A lot of times this plus right here throws people off. And it thinks, well, it says plus, so I have to add. This is an addition problem. Well, it's not, because the signs are different. Look right here, I also had an addition sign, and I subtracted them. This addition right here, all it's telling you is that this 7 is a positive, and this is something different that we're learning this year. Just because you see an addition sign does not mean you're adding. We are paying attention to the signs. And right now, these signs are telling us these two things are different. Right? I have a negative and a positive, and because they are different, we're going to go ahead and subtract them. So when I subtract, I have to borrow, right? Because I can't do 2 minus 5 right now. So I have to borrow. This becomes a 5. That becomes a 12. 12 minus 5 is 7. 5 minus 0 is 5. Bring the decimal, and 7 minus 4 is 3. So I get a positive 3.75. Same, I have to go ahead and borrow 13 minus 5. Right, well, this is going to be 8. Bring down the decimal. 4 minus 2 gives me 2. So this is a positive 2.8. And over here, I already know my answer is going to be negative, but I am adding these. 5 plus 0, 5. 1 plus 3 is 4. And then 8 plus 4 is 12. Okay, so it might take some time, but we need to learn our rules for why we are subtracting, why we are adding, and remember whenever we have decimals to line them up. Okay. Now let's in the first half of this lesson. Now let's go ahead and take a look at the second half. All right. The second half of this lesson has fractions. So whenever we're dealing with fractions, one of the things we're going to look at is we can only add or subtract fractions if they have the same denominator. So the first question you're going to ask yourselves, right? The denominator is the bottom number of this fraction. The top is called the numerator. So do these have the same denominator? Well, yes, they do. If yes, then you're just going to add the numerators across, but the denominator stays the same. So what does that mean? Well, if the denominators are the same, look, I can just add across. 5 plus 2 gives me 7. But I do not do 9 plus 9. The denominator stays the same. The 9 just comes across. So a lot of times when people get confused is they try, because they are adding the top, the numerator, they also try to add across the denominator. And that's not going to work, right? If that's something you have done with fractions, try to remember, or we'll get more practice, or just watch this video as many times as you need. But we're going to go ahead and just add the denominator. Or sorry, the denominator stays the same. We are just adding the numerator. Down here, look, the denominator, are the denominators the same? Yes. So I'm going to write it down, and I'm going to add the numerator. 6 plus 3 is 9 over 7. Now, what do we do if they're different? Well, this gets a little bit tricky. We're going to talk about LCM later on, but you should have probably already learned it last year. So, are the denominators different? If yes, then you have to follow the steps to make the denominators the same. So I have 1/3, 1/6 plus 3/8. I can't add across, right? That's not how our fractions work. What I have to do is find the first number that 6 and 8 have in common? And that is what we're talking about when we say the least common multiple, the LCM. There's a couple different ways of doing this. If in this example, I know 24 is a number they have in common, so I multiply 6 by 4. Whatever I do to the bottom, I do to the top. 1 times 4 gives me 4. 6 times 4 gives me 24. Plus, now I'm going to try to get 8 to get to 24. 8 times 3 will give me 24. Whatever I do to the denominator, I do to the numerator. Whatever I do to the bottom, I do to the top. Because I multiplied the bottom by 3, I'm going to do it to the top as well. So for now, 3 times 3 gives me 9. Well, now that my denominators are the same, I can just add it across. And remember, the denominator stays the same. So 24 is going to stay in my denominator, and my numerator, I'm going to add it across. 4 plus 9 gives me 13. So your answer is 13 over 24. Now, how did we know it was 24? Well, if you know your multiplication facts, right, that should have kind of come to you. But if you don't, well, one of the ways that we can figure this out is by making a list. So I could say, here's 6, and I'm going to go ahead and count by 6s. So 6, if I add 6 to that, that's 12. If I add 6 to that, that's 18, 24, 30. These are just multiples of 6, right? 6 times 1 is 6. 6 times 2 is 12. 6 times 3, 18. 6 times 4, 24. 6 times 5, 30, and so on. Now I'm going to do the same thing, but with 8. 8 times 1, 8. 8 times 2, 16. 8 times 3, 24. 8 times 4, 32. 8 times 5, 40. Well, look, the least common multiple is the first number that these have in common. So I see that there's a 24 here, there's a 24 here. So I try to make them both have a 24 in the denominator. And that is how we got 24. Perfect. Let's see. We have anything else? Okay, the last thing for this lesson is just to practice this one right here. Okay, I want to go ahead and try to add these fractions. Well, there's a slight problem. Okay, I'm going to go up here and check my first rule. Do they have the same denominator? If so, I'm going to follow these guidelines. So let's go ahead and check. Well, they don't. One's a 3, one's a 6. So I'm going to use this one. Different denominators? If yes, follow the steps to make the denominators the same. So I'm going to look at 3 and 6 and see what is the least common multiple that they have. I'm going to choose to make a list. So let's count. 3 times 1 is 3. 3 plus 3, or 3 times 2 is 6. 3 is 9, and so on. Now I'm going to do it for 6 times 1 is 6. 2 is 12 plus 6 is 18. And that's good enough because I can see they actually have the first number that they have in common, the least common multiple, is a 6. Well, we're in luck because this is already a 6. So all I have to do now is take the steps to turn this one into a 6. Well, how did I figured that out up here already. 3 times 1 was 3, so 3 times 2 was 6. And whatever I do to the denominator, I'm going to do to the numerator up here. 8 times 2, well, that's 16. Right? You can use a multiplication table or make a multiplication chart if you're not sure, or just do 8 plus 8, and that'll give you your answer. 3 times 2, we just said that was 6. plus 5 over 6. So now that the denominators are the same, I'm going to keep it that way. I'm going to write it down before I accidentally add them and get 12 because that's not what we're supposed to do. And I'm going to add the numerators across. So 16 plus 5 gives me 21. Now this is an improper, right? Improper fraction. And I think you all learned last year to turn them into mixed numbers. I'm going to say we just leave them like this. Unless it is asking you specifically to write it as a mixed number, I'm fine with you leaving them as improper fractions. So just go ahead and leave them like this. A lot of times we make a mistake when we're trying to convert them to a mixed number. So leave it as an improper fraction. Okay, I think that's it for this lesson. So here's our assignment. If we need any help, just go ahead and let me know. Right? Take care.